We're back on our second day of solving equations for y. These equations are going to be slightly more complicated, and we're going to talk about some of the mistakes that we see from most students. But to begin, we'll go over the vocabulary one more time. Remember that a variable term is the piece of the equation with the letter attached to it, like 5y or negative 3x. The constant term is the good old-fashioned number, so just a number by itself with no letter attached to it, negative 2 or 100. Then you also have the word equivalent. Now you're going to see the word equivalent a lot in these kinds of equations because we're writing the same equation just written in a new way. Remember, these, since they're the same or equivalent, will have the same graph and the same table of generated terms. The steps to solve has not changed, so let's go over those really quickly. We're going to start by drawing the line and finding or locating the variable we're going to solve for. We're going to add or subtract, drag and drop, to move terms to the correct side and use inverse operations. Remember, cross the line, change the sign. We'll combine like terms if needed. I'll be honest, you don't really need this one. It will very rarely happen that you need to combine like terms. But we're going to divide by the coefficient of y and reduce all of the fractions because we're going to have multiple division problems to end our solving for y problems. Now, we're going to spend some time today really focusing on this last little bit, dividing by the coefficient of y, because we're going to look at problems that have complicated coefficients of y. For example, okay, the first example is a lot like what we saw last time. We're going to find the variable that does not have a y in it, because that's the one that we want to move away. Here's the y. And we're going to move it to the other side. Cross the line, change the sign. Again, we are trying to identify or isolate y, so we're going to get rid of the 4 that's chilling in front of it by dividing it away, but I have to do all of the division problems. Every single piece of this equation gets a division problem. Okay, that's 3 things that you're going to have to divide, really 2, and then we end up with our final equation. It is equivalent or the same as the one we started with, just written in a new form. Remember that we like fractions. We're going to leave our answer as fractions if we get decimals or fractions. We want to leave everything as fractions. We love fractions. But if you look at this second example, this is going to be one like you'll mainly see on these notes and on your practice in class, is the same thing. Okay, so we're going to identify that we're trying to solve for y, and so we're going to grab the negative 10x, and we're going to move it across the center equal sign, cross the line, change the sign. Tight. That part hasn't changed. I now have 10x and a positive 13. But did you notice, and this didn't happen at all on the last notes, so I hope we noticed this, that the coefficient of y is negative 2? We need to make sure that when that coefficient is negative, that we drop down the entire term here, that you don't drop that negative sign. That's totally a place we see mistakes all the time from students, so don't let that be your mistake. Make sure that you are keeping the exact same coefficient in front of the y when you do your second step. In the first problem, we had a positive 4, so we didn't have to worry about it because we kept a positive 4. But it is especially important here in the equations that have a negative y term that you don't drop that negative. But from there, you just continue solving the way we always have. Divide by the entire coefficient of y, which in this case is negative 2. And you divide each piece separated by a plus or minus sign by negative 2. 10 divided by negative 2 is a negative 5 x's, and 13 divided by negative 2 would be negative 13 halves. You'll get negative 6.5, but remember, we like fractions. We're going to leave it as negative 13 over 2. Sweet. That is the gist. The problems haven't changed from last class to this class. The only thing that's going to change is that potentially you now have to make sure that that y has the correct coefficient from the first step to the second. It's going to be the only thing that has made these problems any different. Let's shift over to the practice problems. Now, we've gotten a lot of practice, so actually the first 4, I'm going to have you pause on the first 4 and solve these for y to see if you can get the same thing as me. Go ahead and pause the video now and try these 4 problems quickly, and we'll see how we did. Let's check out the first three. That last one I'm going to walk through with you now that you've tried it. So the first one is pretty simple. We identify the y and we say, all right, this piece has got to go. Now, here's something, normally this says x and this says y. I really hope you noticed that the x term was actually the second term in this one and that we had to drag it over. We bring down the 3y, we divide by 3 to every piece, and we have y equals negative 4/3 x plus 3. I heart fractions. Then on the second problem, we identify the y, and we say, all right, this 20 needs to move, and even though it doesn't have an x attached to it, bloop, I can drop it to the other side. Cross a line, change the sign. We'd have negative 5y. Did you keep your negative sign? Awesome. Divide by negative 5 for each term, and we are left with y equal to negative 3x plus 4. For the third one, this one's really cool. So again, we identify the y, and we move the piece without it, bloop, to the other side, cross the line, change the sign. Don't combine them. You cannot combine these two terms. Just write them down. Just literally write them down. This time, we only have a negative sign and a y when we bring it down. Did you notice that that is actually a negative 1 in front of the y? So that gives us the coefficient of the y, or the number we're going to divide by negative 1 for each piece, and we'd end up with y equals 7x minus 5. Great. Now number 4 is kind of tricky because like the y is on the right side of the equation and we want it isolated on the left. There are plenty of ways you could have done this, but the way I would have solved this by grabbing the 5y and bloop, popping it over to the y side. Cross the line, change the sign. But then I also want this 20 to not be there, so I'm going to bloop, move it to this other side. Cross the line, change the sign. That's really confusing, so let's write down the problem as it should be written. This should say negative 5y equal to negative 3x minus 20. I've literally just switched the 20 and the 5y to their opposite sides, but since I crossed their line, I'm going to have to change their sign. From here, I know I'm looking to get this y by itself, and I had to make sure that I didn't drop the negative as a part of the negative 5, and now I know exactly what number to divide every single piece by. Then it's just three little small division problems. Negative 3 divided by negative 5 is 3/5 x. Negative 20 divided by negative 5 is going to be a positive 4. Woohoo, we got it. Awesome. Now again, just like last time, there are multiple choice questions that could be asked for this particular concept. Number 5 says, which of the following is equivalent to this equation? Equivalent means the same, so we're looking at something that is exactly the same, just written in a different format. And hopefully you also notice that all of the answer choices are solved for y, which means that I'm going to need to solve that equation for y to get it to match the format and see which one matches up with it. 3x minus 4y equal to 6 is the equation. Let's start trying to uncover or isolate this y. To start, we're going to take the x term. We don't want it over there. Bloop, cross the line, change the sign. That means that I have negative 4y equal to negative 3x plus 6. Did you remember that, that's not a highlighter. Did you remember that because this says negative 4y that I need to make sure that negative 4 drops down with my y term? Great. We're going to divide by that coefficient, which is negative 4, to every term inside this parenthesis, or on this side, which means that we're going to end up with y equal to negative 3 divided by negative 4, which is 0.75 or 3/4 x. And then 6 divided by negative 4, keep it as a fraction, everybody, is negative 3/2. And guys, this matches answer choice D. That is the equivalent or same expression, just written in a different format. Now what's really cool, and maybe you might have started to notice about these, is we start off with most of these questions in what's called standard form of an equation. X's, Y's, and then numbers. But did you notice that when we're solving these equations, we're actually writing them in y equals mx plus b format? This is something you probably learned about in middle school. This is called slope-intercept form. The reason it's called slope-intercept form is because it literally tells us the slope and the intercept. Math people name things correctly as they should be named. Slope-intercept form. Hopefully you also remember that the slope, that's not a highlighter again. The slope is the m. Please note that I did not circle the x as a part of this. The slope is just the m. Just the m. Not the x, just the m. What is the slope? Cool. Then your intercept, your y-intercept, is going to be the positive b. Whatever number is there, if it's added 5, your intercept is a positive 5. If it says minus 7, your slope-intercept is at negative 7, or your y-intercept is at negative 7. So we're actually learning some really good information about these functions and about these equations when we solve them for y. This is why we learn how to do this. Let me walk you through the first one, and then I'll give you a chance to try some more problems now that we've seen a few. We're going to start by finding the y and being like, all right, that guy's going to be by himself by the end. Cool. So we're going to move the 6x, bloop, cross the line, change the sign. And we're left with negative 3y equal to negative 6x minus 18. We want the y by itself, and we ensure that we brought down the correct coefficient of y. Do those match? Bingo. Got it right. We're going to divide by that negative 3, divide by negative 3, divide by negative 3, so that y is by itself. Negative 6 divided by negative 3, 2. Negative 18 divided by negative 3 is a positive 6. Well, there's my solve for y, but if I wanted to find the slope and the y-intercept, remember that your slope is the number or the coefficient of the x. So in this problem, my slope is 2. And your y-intercept is going to be the number that's after the x, the positive or negative number. So in this case, my y-intercept is 6. I've got my slope and my y-intercept. Okay, let's look at this one, and then I'll give you the last two to try on your own. I know I lied earlier and said that you'd try all of them on your own, but here we go. We're going to draw the line. We're going to find the y and say this is what we're trying to get by itself. So we're going to move the term away. So this 20x, boop, move it across the line, change the sign. I rewrite the equation. Negative y equal to negative 20x plus 15. I double check. I make sure that I'm still isolating for y and that the number that I wrote down in front of y matches the number in front of y that started, including the sign. What number am I going to be dividing by for this problem? Absolutely. There's a 1 sitting right in front of that y, a negative 1. So I'm going to divide each and every term by negative 1. And I'd be left with y equal to negative 20 divided by negative 1 is 20. And 15 divided by negative 1 is a negative 15. Tell me right now, what is the slope and what is the y-intercept for this equation? Yeah, because there's a 20 in front of the x, and because at the end I see negative 15, I know that my slope is 20, and that my y-intercept is negative 15. If you wrote down that the slope is 20x, that's not right. The x is not a part of the slope. It's just the coefficient of x, or the number in front of x, that makes our slope. All right, you've got the last two. Stop the video and see if you can solve for x, or solve for y, and also tell me the slope and y-intercept. Go ahead and pause the video. These are really interesting questions because when you solve the one on the bottom left for y, you move the negative 4 to the other side, bloop, cross the line, change the sign. But hopefully you notice this is when that one step actually comes into play, because we actually do have some like terms over here. The 3 and the 4 are like terms, so I actually can combine them because they're just good old-fashioned numbers. They're constants. So I actually add those together this time, and I would make 7. And then did you notice that the y is already isolated or already by itself? There's no number, there's no negative sign in front of it, which means I'm actually done. And here the slope would be 5, not 5x, just 5. And that the y-intercept would be 7. On the last problem for the bottom left, we find the y, we know this is what we're trying to isolate. We move the x term to the other side, bloop, cross the line, change the sign. Can't combine these because they both don't have x's on them, so I just literally write them down next to each other. Then I'm going to divide by the coefficient of y that I double checked is the same from when I started. If I drop that negative sign, I have the wrong equation at the end. Negative 3y equal to 6x minus 6, so I'm going to divide everything by negative 3. And then I end up with y equals negative 2x plus 2. So that negative 2 is my slope and 2 is my y-intercept. This is the end of day 2 of solving for y. This solving for y skill will come back to haunt you literally all year long. So let's make sure that by the end of today, we have the process down and that we can change an equation into y equals form or into what we now know or remember is slope-intercept form, where we see its slope, m, and its y-intercept, b. See y'all in class.